ladies and gentlemen, we are working on independent and dependent events, as you can see. We have the definition of compound events, dependent and independent events. We have the formula for independent events, which is the probability of A times the probability of B if A and B are independent events. And then we have the more confusing one, which is the probability of dependent events, which is the probability of A times the probability of B after A takes place. Here is the problem we're working on currently. The letters for the word dependent are placed in a box. 2 letters are drawn randomly. They're not replaced. So once the first one is drawn, it's not replaced. And then the second one is drawn. We want to know the probability of drawing 2 consonants. So first of all, would this be dependent or independent events? Dependent or independent? Dependent, because if we're not replacing the letter, the second draw is dependent upon what happens in the first draw, right? Okay? And we know the first draw is just going to eliminate a letter. So what is the probability that we're going to choose a consonant on our first draw? So hopefully Mr. Walker taught you guys the difference between a consonant and a vowel, or your second or third grade teacher, I should say. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. How many consonants do we have here? Everybody?
6.
So we have 6 consonants. So what is the probability of drawing a consonant on your first draw? Because in order to draw 2 consonants, the first draw has to have a consonant. What is the probability, everybody? 6/9. So that would be the probability of the event we want to have happen, drawing a consonant, is 6/9. So now the next event, which is drawing another consonant, right, is going to depend upon the first event in which we drew a consonant. So what is the probability, assuming we drew a consonant in the first draw, that we're going to draw a consonant in the second draw? Everybody.
5/8.
5/8. So just to be clear, the probability of A was 6/9, and the probability of B after A takes place, and the fact that we lost a letter, one of the 9, and we lost a consonant, one of the 6, we are now at 5, and we are now at 8. So do your math. What is 6/9 times 5/8? Michael. And can we reduce that? To what?
15. 10 over.
What does this reduce to, Tricia? 15 over 36. And can we reduce that? To what, Isa? 5/11. 5/12. So the probability of drawing 2 consonants from the word dependent would be 5 out of every 12 times. Yes or no?
Yeah.
And this would be an example of dependent events. Yes or no? Okay. All right, let's go on to number, I'll leave the recording going here. Let's go on to number, what are we on, you guys? 8. What is, so you got to decide if this is a dependent or independent event, and then the probability using one of the 2 formulas we just went over. What is the probability of rolling a 3 on a fair number cube and flipping a tail with a quarter? So we have 2 different events, so therefore we have compound events here. We're rolling a number cube. We're flipping a quarter. What is the probability we're going to get a 3 and a tail? Dependent or independent, my friends?
Independent.
Independent. So if it's an independent event, if we're dealing with independent events, we're going to our formula for independent events, which is the probability of A times the probability of B. So what is the probability of getting a 3 on a fair number cube, Linnea? 1/6. What is the probability, Linnea, of getting a tail on a quarter flip? 1/2. So Linnea, what is the probability of getting a 3 and a tail? 112. This makes sense? Yes or no?
Yes.
Questions, comments, quandaries, quibbles, quotes, queries?